Hyperbola. Okay. Hyperbola we are going to get when the plane cuts the double napped cone. Beta is what the condition we are going to have. Beta represents, beta is less than alpha means like this, the shape you see here very clearly. Two sides we are going to get. When it cuts, upper one part you are going to get, lower another part you are going to get. So if that beta is greater than 0 degrees and it is less than alpha, then the conic section is called a hyperbola. The section whatever you are getting, the conic section is called as a hyperbola. So now as per this is when you are taking the conic section. Ellipse we are going to get. Can anyone tell me what is the definition of the ellipse? How do we get? Set of the points whose sum of the distances from the two fixed points is equal.
Yes, sir.
Yes, in case of ellipse, that is. In case of ellipse. In the same way, differences. Okay, differences should be taken into consider here. Set of all the points whose differences from the two fixed points is called a hyperbola. Like this, the example you can take from here that P1, F1 and F2 are two fixed points in this case. Okay, F1 and F2 are two fixed points and P1, F1, P1, F2. So the difference is P1, F2 is distance is more. Difference I am saying to you, P1, F2 minus P1, F1. P2 point whenever you take P2, F2 minus P2, F1 is equals to the P3 point you take on the that side. So P3, F1 minus P3, F2 we are going to get. All are equal. So in this case, this F1 and F2 are called as a focus and the plural of the focus is?
Foci.
Foci, very good. So this is we call usually in case of ellipse, the line segment joining the two foci is called as in case of ellipse. Compare with the ellipse so that you will be able to remember. Okay. So in that case, we are going to call it as major axis, but here we call it as a transverse axis. What do we call here? Transverse axis. The point of intersection of this transverse axis with the hyperbola is called a vertex, and the midpoint of these two vertices is called a center. A line which is passing through the center perpendicular to the transverse axis is called a conjugate axis. Did you understand? So the distance between the two vertices is the length of the transverse axis. Actually, transverse axis is what? Here it is a line. Line is not going to have the length usually. Line segment is going to have the length. But distance between the two vertices whenever you are taking, it is the length of the transverse axis. We call it as a length of the transverse axis. Okay.
Sir?
Yes, tell me.
Sir, we can call minor axis to the conjugate axis, sir.
What? Come again?
Minor axis, sir. Conjugate axis. We can also call, no, sir.
No. In case of the ellipse, we call it as a minor axis. But here, minor axis cannot be normally. That is, in case of ellipse, it is minor axis only.
Yes, sir.
We don't call it as a conjugate axis. Okay. Now here, in this situation, the distance between these two vertices is that AB we are going to denote it by the 2A, and OA is equals to A units and OB is equals to A units, and length of the semi-transverse axis is A units. Length is nothing but distance between the two vertices is length of the transverse axis. So if F1 and F2, usually it is F1 and F2, between the distance between the F1 and F2 is denoted by 2C. The distance formula of a focus whenever you are taking into consider here, distance of the focus from the center is C. It is denoted. So that point, whatever we are going to take it, is called as, means the line whatever it is touching the these hyperbola is called tangent here, usually here. So whenever you are taking into consider hyperbola, that relation between the C is nothing but here. What is C here? O to F1. O to F1 and O to F2, whatever the distance is called. So length of the conjugate axis is equals to CD here. Length of the conjugate axis is equals to CD. And C and D, how do we get here? That CD is denoted by 2B. Usually in case of this, you are going to denote by the CD, and OC is equals to OD is equals to B, and which is semi-conjugate axis. So A, B, C these are the three things. And in case of the relationship between the ABC, in case of ellipse, what? A is more, because foci will be middle in case of the ellipse. So compare these two things. I'll explain to you after completion of this. Okay, very clearly. So A distance is more. That's why we write the relationship between you can remember the relationship between the ABC in case of ellipse. A square is equal to B square plus C square. But here when you consider that B is OC here, what we are going to get here, B value, in this situation, B square is equal to C square minus A square we will get, and that is can be written as B is equals to under root of C square minus A square. Under root of C square minus A square. So here, if you observe that C is more because the distance from the center to focus is more than the distance from the center to vertex. Here, what are the vertices? Can anyone tell me once again? What are the vertices? A and B are the vertices, and center O to A distance is A, center O to C distance is O to F1, focus distance is C. So always you do remember that the distance from the center to foci is always denoted by, in a hyperbola or in case of ellipse, C only, that is. But when you observe that hyperbola, C is outside the A. So that's why C square is equals to A square plus B square. Like that, easily you can remember. This is the one easiest way to remember. I am saying C is always fixed. Vertices are always fixed. Okay. So the difference of the distances of the point A from the F1 and F2 is K. You consider here the differences. AF2 minus A. AF2 can be written as AB plus BF2 and AF1 if you are subtracting as per the definition of the hyperbola. You consider this as a equation number 1. Okay. And difference of the distances of the point from the F1 and F2 is BF1, because that is also constant now, because B and A are the points on the hyperbola. So that can be written as a AB plus AF1 minus BF2. This is you consider as a second equation. These both are constants are equal, because that is constant from the equation number 2, and we are going to, and AB will get here. So BF2 is equals to AF1 we are going to get at final. BF2 is equals to AF1. Okay. So concentrate here, slowly you observe the figure also. Whatever the figure here it is there, that also you need to observe. BF2 is equals to AF1. So B is here. I'm showing the arrow mark, and F2 is here. BF2 is equals to AF1. We are going to get it. Okay. So from the equation number 1, we are going to get it as a k value as, what is k here? K is equals to 2a, we are going to get it. From the equation number 2, if you are substituting these values, both are equal, k is equals to 2a, we are going to get. That means the constant value is 2a, we are going to get. The constant. What is that constant we have taken? K. So how do we get it is 2a, that you need to remember. Okay. Did you get my point? So the difference you need to try to understand here when you compare the ellipse and the hyperbola. In case of the ellipse, if you take ellipse, it will be like this. Is the board visible to you?
Yes, sir.
Okay.
Yes, sir.
The difference is only the easiest way is you need to concentrate like this. When you take the ellipse, the focus will be here f1 and f2 will be like this. So here to here the distance is c. Here to here distance is a. This distance is a. And this distance is b. So as in all these three, the distance which is more, a is more. Just I am blindly saying to you how do we remember, but it is not the proof. Proof already we have discussed how do we, but there will be a most of the students will have a confusion regarding that. In case of the ellipse, we will get a square is equal to b square plus c square, or in case of hyperbola, we will get a square plus b. That easiest way to remember is this a is distance is more obviously whenever you take the major axis x axis or major axis as a y axis, whatever it may be. So a is more. Okay. So whenever you take here a is more, here the relation between this a is more, that's why a will be equal to sum of the squares of the remaining two. A square is equals to a square is equal to b square plus c square. Even when you take the ellipse in case of major axis as a this one. So what are the coordinates of this one? These coordinates, can anyone tell me? Can anyone tell me what are the coordinates of this one? Ellipse.
A comma 0, sir.
AB, sir.
Yes. This is a comma 0. This is minus a comma 0. This is 0 comma
0 comma A, sir.
not a, b.
0 comma B. B, sir.
0 comma B.
Minus b. Minus. Okay. Now you tell me what are this point. Okay, shall I draw it little bit bigger one? Okay, like this. Ellipse is taken. So what are the coordinates of this one?
0 comma B.
0 comma
B.
b.
0 comma A, sir.
A. This confusion. See here, yesterday very clearly I told you that in the ellipse case, whenever you are going to take the equation of this ellipse is x square by a square plus y square by b square is equals to 1. Equation of this ellipse is x square by b square plus y square by a square is equals to 1. So which is greater? That is A. A is means in the A and B comparison, you can remember this confusion will be there. That's why I am stressing on this point. Which is greater value, that is A. So this length is more now. Obviously, you can observe that this length is more now, isn't it?
Yes, sir.
So when that length is more, easily you can say that what is that coordinate, what we are going to get it here, that coordinate value. That point you need to remember here in case of the whatever it may be, the axis is taken into consider. Whatever it may be, the axis is taken into consider. Here the confusion obviously will be there for the most of the students, but only blindly thing you need to remember is in case of ellipse, A is more. Either it may be this one or this may be. So A is represented. This is A. This total length is 2A. This total length is 2A. So this is A. So A means it is on the y-axis. So x coordinate will be 0, 0 comma A. This is 0 comma minus A. This point is B comma 0. Isn't it? This point is 0, sorry, minus B comma 0. That's why we are going to get the equation of this parabola, sorry, this ellipse as a x square by b square plus y square by a square equal to 1. This is a story about the ellipse. Now let us compare this with the hyperbola. When you are taking hyperbola, someone is... Okay. When you are taking hyperbola, so hyperbola, in case of hyperbola, when you observe that, let it be like this one, compare. So when you are taking the axis like this, the hyperbola we are going to get it like this side and this side. So these two are the vertices. This and these are vertices. Here in this case, these two are the vertices. These two are the vertices. So, and the foci will be normally here. F1 and F2. So you do remember that from the center onwards, the focus distance is in both the cases it is represented with C. This is C. This is C. So F1, F2 distance is 2C. And here this vertex is from the center to vertex is always denoted by A. So these distances here in case of A is more or C is more here, you see. You tell me whether I have written right or wrong here.
A is greater, sir.
This confusion will be there. This confusion will be there for all the students. Focus will not be here in case of hyperbola.
Yes, sir.
In case of hyperbola, inside here will be their focus, F1 and F2. This confusion will be there for every student. So that's why A will be smaller here in case of hyperbola. You do remember that ellipse case A is more. In case of hyperbola, C is more. Means center to C distance should be more. I already conveyed this one in the previous video whenever I am showing to you. Isn't it? So vertex is this one. A is smaller, C is more. That's why in this case the relationship between the ABC is C square is equals to A square is plus B square. C more, na? As C is more, C square is equal to A square plus B square. Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Now here, what are the coordinates of
Yes, sir.
these coordinates is A comma 0, this coordinates is minus A comma 0, and the coordinates of F1 and F2 are C comma 0, sorry, minus C comma 0, this is C comma 0. So you do remember only this point so that easily you can remember for a long period of time. Only thing is that in case of ellipse, A is more because the vertex inside will be their focus. Focus will be inside inside the ellipse will be there. When you take hyperbola also, you can call it is inside only, but the C distance is more. So this main point you need to remember in case of the hyperbola. The relationship between the ABC. Main thing is the relationship between the ABC only. So in case of the hyperbola, the eccentricity is equals to C by A only. The relationship between the ABC, we are going to get it in the same way. Eccentricity in case of hyperbola. Hyperbola equation. What is the equation of the hyperbola? X square by A square minus Y square by B square is equals to 1. So how do we get the equation of the hyperbola? Let us see. Okay. Is it clear?